dimensional analysis, and unit conversions. Dimensional analysis is a problem-solving process that is used to convert units of measurement. It utilizes conversion factors, which are numbers that are used to convert one set of units to another set. Conversion factors have two main components: the units that you start with and the units you want to convert to. One is in the numerator and the other is in the denominator, or vice versa. These are derived from defined unit conversion relationships, such as 1 inch equals 2.54 centimeters or 1,000 grams equals 1 kilogram. Conversion factors are the same quantity in the numerator and the denominator, except in different units. This means that conversion factors are equal to 1. To demonstrate this, let's use the equation 1 inch equals 2.54 centimeters. There are two unit conversion relationships we can write using this expression: 2.54 centimeters over 1 inch and 1 inch over 2.54 centimeters. Let's focus on one of the conversion factors. This expression here equals 1 because if I substitute in 2.54 centimeters for 1 inch using this expression, it becomes 2.54 centimeters over 2.54 centimeters, and everything cancels out to equal 1. Now, let's try an actual example. Convert 50.6 centimeters to inches. There's a set of steps I developed to do unit conversions. First, determine the unit conversion relationships you need based on the units you start with and the units you want to convert to. If there are multiple units, match up the dimensions first. For instance, if we wanted to go from meters per second to kilometer per hour, we would match up meter and kilometer as the length dimension, and we would match up second and hour as the time dimension. We would then find the corresponding unit conversion relationships, which would be 1,000 meters equals 1 kilometer and 3,600 seconds equals 1 hour. So in our example, the unit conversion relationship we want is 1 inch equals 2.54 centimeters. Second, write out the initial quantity in terms of its numerical value and units. Use a horizontal line to divide the units in the numerator from those in the denominator. Leave the denominator blank if there are no units in the denominator. Third, from the unit conversion relationships, multiply the initial quantity by the conversion factor that will mathematically cancel out the original units. For example, if we start with centimeters in the numerator, we would want to pick a conversion factor that would have centimeters in the denominator to cancel out the units. Therefore, we should multiply by 1 inch over 2.54 centimeters. The centimeters will cancel and we're left with inches in the numerator. Fourth is to use a calculator to compute the final answer and to retain the same number of significant figures as the original value. Significant figures should not be added or subtracted during dimensional analysis. Therefore, our final answer is 19.9 inches. Alright, on to a couple more examples. Convert 356.6 centimeters per second to meters per hour. We have a length dimension and we have a time dimension. So we'll match up the centimeter and the meter as our length dimension, and we'll match up the second and the hour for our time dimension. So the two unit conversion relationships we need for this problem are 100 centimeters equals 1 meter and 3,600 seconds equals 1 hour. Second, we'll write out the initial quantity we have, which is 356.6 centimeters in the numerator, and we'll write seconds in the denominator. Third, we'll go ahead and multiply by our conversion factor. We'll convert the length dimension first, and to do so we need to put centimeters in the denominator and meters in the numerator. So we'll multiply by 1 meter over 100 centimeters. We'll convert the time dimension next, and to do so we'll put seconds in the numerator and we'll put hour in the denominator. So we'll multiply by 3,600 seconds over 1 hour. Last, we'll calculate our final answer and retain 4 significant figures in our final answer. We end up getting 1.284 times 10 to the 4th meters per hour for our final answer. Alright, let's do one last example. Convert 3.52 grams per milliliter to kilogram per meter cubed. Alright, first for the mass dimension, we want to go from grams to kilograms. And the unit conversion relationship we have for that is 1,000 grams equals 1 kilogram. For the volume dimension, we want to go from milliliter to meters cubed. We know that 1 centimeter cubed equals 1 milliliter, and also that 100 centimeters equals 1 meter. But hold on, we need to go from centimeters cubed to meters cubed, right? So we need to cube both sides of our expression. Because of the power of a product rule of exponents, both the units and the numbers get cubed in this case. Therefore, we get the expression 1 times 10 to the 6 centimeters cubed equals 1 meter cubed. Second, we'll write out the initial quantity we have, which is 3.52 grams in the numerator, and milliliter in the denominator. Third, we'll multiply by our conversion factors. We'll convert the mass dimension first, and to do so, we'll need to put grams in the denominator and kilograms in the numerator. So we'll multiply by 1 kilogram over 1,000 grams. We'll convert the volume dimension next, and to do so, we'll put milliliter in the numerator and centimeters cubed in the denominator. So we'll multiply by 1 milliliter over 1 centimeter cubed. We still need to get to meters cubed in the denominator. So we'll multiply by 1 times 10 to the 6th centimeters cubed over 1 meter cubed. Last, we'll calculate our answer and retain 3 significant figures for our final answer. And we end up getting 3.52 times 10 to the 3rd kilogram per meter cubed for our final answer. Please hit that subscribe button if you haven't already. Thank you for watching, and I hope you learned a thing or two about science.